Hello, and we're live. Welcome back. My name is John Stevenson. This is the Practicalli Clojure study group, and today we're continuing with the building a fairly simple API in Clojure. And so we're going to we're going to actually create an API, a simple one with a few different endpoints, and it's going to be self-documenting using Swagger. We can have some tests around it using Clojure test and ring mock, and we're going to also put in some specification around it as well using schema, so that we can ensure that the data coming in, or if somebody sends us some incorrect data, we can kind of give them an error message and so on. Okay, let me share my screen. Sure. Oops. So I've started to document this inside the Practicalli Clojure web apps website, and this is it's all in the server-side API work we're doing. I'll just update this. There might be a few little bugs in this, but hopefully it's good enough to follow. Okay, so in last week's episode, we built a very simple server-side application using a couple of libraries, one called Ring and one called Compojure. And we built a very simple project doing that, just to use those libraries. It's fairly straightforward. And we're going to build on top of that basically what we did last time. We're going to create a new project, but we're building on the libraries that we've used, and hopefully the little bit of experience we gained from building that server-side website. So we're going to run our API as a server-side application as well. So it's going to run on a back-end machine, and if our API was really popular, then obviously we'd need to be able to scale it up, and that works. It's a lot easier to do on the server side than it is on the client side. So if we actually look at some of the pieces we're going to look at today, we're going to have a look at compojure-api, which is a library, but it is also a Leiningen template to help us build the project. And it also has like a plugin called lein-ring plugin, which will help us start and reload the code. So basically, this is going to give us a project. We're going to have what we call an adapter, which is essentially the Jetty application server. And so that's going to be running. So that's the Java application server that we run. And the Ring basically helps us take requests to our server. So they come in as HTTP object requests, and Ring will convert them into a nice Clojure map for us, so that the data is really very simple to use, really very simple to understand and work with inside Clojure. We can put middleware in there as well. So the compojure-api allows us to reload the code as we're developing, which makes it a lot faster and a lot nicer experience when we're developing code. And a middleware will just might do something with the request maps we're putting in and push it to, instead of having like general routes, we're specifically having API, what they call endpoints that you can call. So you go to a particular web address and it gives you a particular response, and it could just be a simple piece of text. It could be more likely to be a piece of JSON, which is JavaScript object notation, but it's quite common these days to use this kind of simple structure called JSON to pass data backwards and forwards between APIs. And if it's a simple thing, we can handle it within inside the API, or we might write one or more functions to be able to deal with the request on that particular API, just like we were doing previously with Ring and Compojure, where we we had different requests coming in here, and we would route, depending on the URL, we would route them to different functions inside Clojure as well. But if you didn't see last week's, then go and listen to last week's broadcast, then go and have a quick look. Okay, so that's the basics of how we're going to use. So we're going to see the code that kind of drives this. We're going to use, actually, it's not prismatic schema, it's plematic schema. I've got a book there already. But we've got a schema that will validate the shape of the data that we're using. So if somebody wants to send us some, for example, send us some JSON as part of the API request, then we can check it. And we can also check any of the code that we're generating to make sure it's part of the schema as well. And we can also just return the schema as an example. One of the nice things about the template is it uses something called Swagger. And we'll have a look at that as well. I think I briefly mentioned that last week. But it's a nice way to basically self-document the API as you're building it, so you don't have to do an awful lot of work to be able to define the API. Swagger will kind of just look over the APIs that you write and create a nice user interface. And the user interface allows you to go in and actually go and test the API as well. So if you want to deliver, there's no extra work you need to do to be able to kind of let people know how to use your API. Swagger basically tells them how to do it. It basically creates a nice website for them to use. And so I briefly mentioned lein-ring. We've got this lein-ring plugin. So we're going to run our code slightly differently. We're going to run lein-ring on the command line, and that will allow us to reload our code. And there's some other links in there as well. I've got. There is other alternatives to using Ring and compojure-api, but it's a nice kind of next level up from building applications with Ring and Composure. It's pretty much the same. It's the same kind of code, so it's an easy way to move on from server-side apps to an API. Okay, so let's have a look at Composure template. So this is just a Leiningen template. So in case you haven't come across it before, Leiningen is our tool in Clojure for automating projects, building projects, and also packaging up projects and for deployment as well. So we can run line, which is our application. We want to create a new project. We can, in this case, we can use a template. So we're not kind of starting from scratch. We've got a few bits of code in there already, and then we can provide a project name. And we've optionally, for this particular template, we can either add Clojure Test or Midge, which are two frameworks for testing. So this adds a little bit extra code in just to make it easier for us to start testing our application. And it does include some tests in there as well. So we've got examples. Clojure Test and Midge, there's not a huge amount of difference between these two. Actually, Midge is based on top of Clojure Test and can actually run all the Clojure tests. It's more it's a slightly more kind of BDD style approach to testing. But Clojure Test is kind of built in, so we're just going to use that as well. So what I've done for this project is just gone in and created line new my API Clojure Test. So we could actually go and just do that, show that in action. So I'm just opening up my terminal, and let's already got one there. So I'm just in. Oops. In a directory where I want to create a project. So let's push that in there. So line new, I'm going to call it something slightly different now because I've already got my API. So I'm basically creating a new Composure API using this Composure API template. The name of the project is my API demo, and Clojure test is an option we're adding. So if we hit that, should be pretty quick on my machine because it's already downloaded all of the dependencies. It might take a few seconds extra for you to download any additional libraries, but once you've downloaded them, then again, you can see it's pretty fast. So let's go to our editor. Any questions so far? There's no questions so far. Let's go and create a new layer, API demo. That's my file, and it was in project study group. There it is, my API demo. Oops, wrong button. Let's go and have a look at the project file. This is configuration. And there we go. So yeah, this is so this is a dev project. So this is just a piece of Clojure. So we're going to call this dev project function with all this data, and that defines how our application is configured. Most interesting things are the dependencies. So these are libraries that we're going to include in our project. And so this is using Clojure 1.8. We could actually bump that up to Clojure 10, which is the latest version. And we could actually go and check, see if compojure-api is the latest version as well. So Clojure is a library itself, and then we're using this other library from a company called Mitosin, which is a really great Clojure company based in Finland. They do a lot of really interesting work, and they've got some really nice libraries and templates there. And they've got this compojure-api library, and it's version 1.1. Let's just go and check to see if that is the latest one. So if we go to clojures.org, we can go and search for any kind of anything that's kind of published. Any libraries that are published for Clojure are available on Clojures. So we can go and Composure API. Oh, look, it looks like I've already searched it already. And there's usually quite a few things. If we do a find for Mitosin, there we go. There is a 2.0, but it's alpha, so we might not use that just yet. But there's probably earlier versions. So there's quite a few earlier versions as well. Yeah, so 1.1.1.1 seems to be the latest version that is kind of not alpha yet. So we're going to stick with that one. I think that's a good idea. And this just shows you how to add this library as a dependency based on which build tool and which dependency management tool you're using. So we're using Leiningen. You can also use Clojure CLI, which is kind of the newer approach that Clojure is taking. But let's stick with Leiningen for now. Okay, so let's go back to our code. And anything else interesting? So we've got this ring definition here. So this is because we're using the ring handler plugin, which is down here. Oops. Yeah. So we've got this plugin. So we've got this lein-ring plugin here, which we're using, and this allows us to start our application and reload our code in. So we need to tell ring what our main entry point into our application is. So it's looking for something called a handler. So like in previous examples, we've done a main in here. So you might see main, and then we give a particular namespace. Core kind of thing, and that will be our entry point. So our applications, our build tool, when we did line run, we go and look for namespace.core. There we go, and look for a like a main or a minus main function. This is kind of the same thing, but for specifically for the ring handler. So you would need to use lein-ring whenever you wanted to run this application. And yeah, it's defining a handler, which is basically a function that's just going to take all the requests and list, basically be listening our listening application that's running in our Jetty web application. If we want to package it up, then we can give it a name. So this is the uberjar name. So we can just basically package it up and just run this on the command line, just using a normal Java command. And we've got some development dependencies, just some libraries that will help us while we're developing. So we've got the servlet definition, which is part of the Jetty makeup. So if you're doing anything server-side, then it's good to have that. Cheshire is a nice tool, a nice library for generating JSON. Ring mock is to help us do some mocking tests, which we'll look at. And I think that's it really. So yeah, so essentially we've got Clojure, we've got Clojure compojure-api, and that's going to include a whole bunch of ring stuff as well. And actually have a look at, I think we go back and look at the, oh, I didn't include the link there. Maybe it's back inside this side. Oops, sorry. Yeah, if we're going to look at the Clojure, I think I actually still got it open. Oh, there we go. Yes, I have. If we're going to look at the Clojure, the compojure-api project file, you can see it's got a whole bunch of dependencies. So just by including compojure-api, we also include these other dependencies that are dependencies of this project as well. So yeah, so this is the project CLJ file for compojure-api, and you can see it's got a whole bunch of things. It's got prismatic schema, plumbing. It's got some stuff for doing time with. It's got rings. So we're using ring, and we're using composure, and it's also including some spec, which is another way for us to define a specification for our code, whether it be functions or data structures. And it's also got things like ring swagger and swagger UI. So we'll see that in action because it'll generate us a nice UI for our API. And we don't really need to know all the rest of the stuff, but there's a whole bunch of things. So there's a bit of work gone into this. And this is for version 2, so I should really have looked at version 1.x. Yeah, so this has got Composure and Cheshire, and this is Potemkin, and a bunch of. So this is using prismatic schema and ring, but this has still got ring, middleware, and Composure in there as well, and ring swagger. Boom. Okay. And there is a nice kind of tutorial that kind of walks you through all this stuff on the compojure-api thing there as well. So let's have a look, see what we've done so far. So we've got my API. Look at the tree. So we've got a project file, we've got source, we've got a handler namespace with our, we should contain our app, and we've also got a test namespace. It's got a few little tests in as well. So let's have a look at those. Oops. Look at the source file. There we go. So we source my API demo handler. Okay, so we've basically got our namespace with a few includes. So we're including compojure-api, we're including ring util response, so we can. So this is just a specific part of the ring library that's just going to allow us to create responses, and we've got schema to allow us to define things like this pizza and things that we'll have a look at in a minute. And then we've got our app in here, which just defines a whole bunch of endpoints. So that this is kind of an endpoint. There's basically web addresses we can go to underneath the API. So we can go API plus, and it should give us some answers. So we've got 2 in there. So we've got plus and echo. Let's have a look at running this application. So let's go back to our terminal, and to run this, look in there. So run doing line run, which we do normally, or line REPL, we're actually using the ring plugin, so we have to use lein-ring, and we're going to run a server. So we just do lein-ring server. Just take a few seconds to start up. It needs to start up the Jetty application server, and then once that's started, it will load in our Clojure application, and it should say, oh, it actually opens up our web page for us as well at the Swagger user interface. So this is what our API looks like already. We can go in and have a look. So if we can actually click on this, click on the name of API, we can also go in and hide this as well, list operations. We can expand the operations here, so we can have a look at specific things. And we've got some in our API. We've got our API plus, API echo, so we can actually go and click on these and see what they do. And all this documentation is just being generated for us from the code that we haven't actually written any code yet. We've just used the template. But we can see kind of the example it's going to give us. So this API plus is, as it says here, it's going to add 2 numbers together, and we can put it into numbers as x and y. Let's put 20, 24. And it's giving us the type that they're supposed to be as well. So if you're using a language that's typed, then you would need to do that. If you're just using REST, then this is the types it's just going to coerce into as it runs. We can also specify kind of the type of data that we want to get back. So we can have JSON. We can have Eden, which is if you're just talking Clojure to Clojure, you can get some Eden back as well. So that's quite nice. If we're getting back JSON, we would need to convert it into. We will probably convert it into Eden into Clojure, so it's nicer to use. But we can have a look at that in a moment. So let's just try this out, and we have got a result of 44, and it's showing us how to actually do this. So it's actually giving us a command line we could actually run to also emulate this, so we don't have to just do it in Swagger. We could also set up some scripts to be able to test our API just using scripts. It's nice to know whether it's, because if there's a bug with your code, then it's nice to know whether, especially with your client code, so any code that wants to use this API, it's nice to know whether you've got something wrong with the code or it's something wrong with the API. So it's giving us options to kind of test the API in other forms. So we can go to, if I go back to the terminal window, if I open a new terminal, and I do Control-Shift plus, that's not what I wanted to do. Oops. I copy that. I done. There we go. To do that, I get the same results there as a result. So I can test this on the command line. I could write a little simple script to be able to go off and test all my APIs just to see if they're up or even ping them. I could actually attach this to some kind of simple monitoring system as well. So I could monitor whether an API had stopped responding to something, which is always a useful thing to do. Because if you're building an application and it's using one or more APIs and something goes wrong with your application, it could be the API that it's using that is causing the problem. So it's good to kind of be aware of that outside of your own application. So it's showing us here the result we're going to get back. So it's sending back the result as a JSON map, which looks very similar to a closure map, except we've got this colon here as well. If I actually went in and changed the response content type and changed that to Eden, and let's just change this to show you that it's actually doing something different, and I click try it out. The curl thing is pretty much the same, except for it's defining that this application Eden is the type of data that we actually want to return, and it's giving us a URL, so we can actually do this inside our browser. So we can actually copy tab. So if you've got some browser-based tests as well, you can see that we actually go in and we can actually see the result. Again, it's not very pretty, but it's just the data. That's all we're expecting back from the API itself. So our application would need to do something to consume that, but it gives us another way to test that out. And we can also check, it's showing us that there's a response code of 200, which means that that was successful. If there's a response code of 400, that means that there's something's gone wrong. And we can kind of show that in when we have a look at the echo one in a moment. You can see that the result body, response body here, when we're using application Eden, is almost the same. We've just moved the colon there, and we're not using a string for the key. So this is a proper closure map. We wouldn't need to translate this from JSON to Clojure. We can just get the response back as Clojure. So if we're running a Clojure application and we just want to consume something, and the API allows us to do it, as been defined in the way that allows us to do that, we could just return Eden, and that would save us a little bit of processing of the JSON format. Anything else in here? No. Yeah, so there is some header information as well, so you can actually go in and check that where it's coming from and so on. So that's just a simple get request. So we don't need to give it. Well, we're giving it some arguments here, and just in terms of parameters that we're providing on there. We might have some APIs where we just call something and get a result. We'll have a look at that. And we can also do get, we can also do post functions where so if we have a form, we might be posting some data to our API, so then it can give us a result based on the information that we that we provide. In this case, we're using, whoops, I haven't been looking at the questions. I'll come to the questions in a minute. Sorry, I got carried away by explaining Swagger because I quite like it. Yeah, so here we've got an echo, which is a post. So we need to provide some information, and it's giving us some example values we can use. If we just click on this, then it's giving us like a template we can use. We can go in and put in some information in here. So it's what do we call? I want a pizza. Only there are other pizzas, and with extra pepperoni. I do like pepperoni. We can specify the size and an origin country where it comes from. I think I've said it for phi, and then a city. Which I think if we go back to the code, just briefly, so we've got this schema that defines our pizza. So we've got valid numbers here: large, medium, small, and string. Well, city is just a string, so we could actually put in any string in there we wanted to. But London is now in Finland. For the course of this broadcast. There we go. And I'm just going to return, in this case, I'm just going to get it to return JSON. We're sending JSON in, so we're going to return JSON as well. So this is the data we're going to send to the API when we do a post. and hopefully we get some interesting information back. So it basically says it's going to echo a pizza. So let's try that out. So let's have a look at the response. Okay, so it's basically just returned the pizza because it's a valid pizza. If we put in, if we were really hungry and we wanted an extra large pizza, this big enough? Well, let's make it bigger. Yeah, so I'm putting in an extra large pizza in the size of this pizza that I'm requesting. And if we go and try it out again, so this kind of initially came up with like a 200 response, and it returned the pizza. If we try this out now, then what do we got? Oh, we've got an error. Oh no. So we've got a response code of 400, but because we've got a schema, it's actually giving us some information about what we should be using as a size. So in our size, it's basically saying that the size we specified, which is XL, is not in the set of data that we're allowed to use for a pizza. So this is what we've defined in the schema for pizza. So if somebody tries to use our application in a way that we don't support, then at least it gives them some interesting error messages to work with as well. Yes, thank you for answering that question. There we go. Okay, so that's and this is all generated. So if we actually go and look at the code we've created with the template, so we didn't actually have to do any work really to create the Swagger UI. It's all been done for us. So we're defining our app, which is using this API from compojure-api. We're just basically including a piece of Swagger configuration in here. So this is the configuration we have. So we want a UI, we access it from the root, and the specification is in swagger.json. And we've got some information in here that we can change to make it more interesting. And actually, obviously, this is just generic text from the Composure template, so we can actually update that to really describe what our API is actually doing. And yeah, but that's all we need to do. And then using Swagger and Swagger UI libraries, it will just take this and create like the API documentation and the website from the APIs that we've defined in here. So we don't need to like add any specific documentation in there for generating that Swagger UI. It's all done for us. Okay. So I'm going to switch over to a different project, one I've been playing around with. Let's see. I'm just going to close that project off before I forget, so I don't need that. Don't need that one either. There we go. Oops, that's not running either. Cool. So let's see, tab. So here's one I've been working on earlier, and this is the one that's got the code I'm starting to push to the GitHub repository. So all this code will be online by the end of the broadcast. That's not the one I wanted. There we go. So where we go? Let's go back to that's the test. We didn't look at the test yet, did we? No. Oh, let's just have a quick look at the test from the previous one. Next. So we're using Clojure test. I think I did cover that in a previous broadcast to show you how to do Clojure test is simply we have a function called def test, which we use to define a series of tests. And our tests really, if you've used other unit tests, you might have like an assert. Here we're just using is. So these are our kind of our unit tests here. You're going to see if the status response is, so it is something true basically. So is it equal that the status response is 200? So is it a correct response that we're getting? And is the result of the body 3? So those are the tests that we're doing. And we have a let function to define some local names. So we're going off to get a request, and we're mocking our request using the ring mock library, and it's going to get the so this is the get protocol for the request, and this is the URL it's going to use. It's going to call, so it's going to call our plus URL, and it's going to provide two values, 1 and 2, which our plus value is going to add together. And so we get a response there that we can go and check. So this is just going to check the response map that we get back here, and it's going to say it is in the map. Is where the status key is there a value that's equal to 200? So is it a correct response? And then the body, we're just passing the body using Cheshire, which is again the library for passing the JSON JSON in the response. So we have a look at the body of the response, which is the JSON structure. We pass that to get the value out as a Clojure map, and then in the Clojure map there's a result of that from that body, and the result points to a value of 3. So apart from actually getting a response, pretty much everything else is the same as Clojure tests that we've covered before. But we'll write a few more. I'll show you a few more examples of tests as well. And here's an example of using Cheshire again, where we can slurp in a body. So it's just pulling in a URL or a file, and it's going to pass a string and turn that into a Clojure map rather than a JSON form. We'll have a look at some of those examples as well. Okay, let's have a look. Previous. There we go. So I've added a few more. Well, I've done a little bit more in the test. We'll come back to that in a moment. The handler. Bigger. So I've just so this is the handler that we've created just as we created before. I'll just put in a bit of extra documentation in there, just to explain it. I've added a little namespace. I've just added a little namespace for some utilities, but that's the only thing I've added to the namespace of the handler. There's nothing else there. So we'll have a look at just basically create a particular file, particular function. Something that I thought I might do over again. So we've got so the template gives us this schema for pizza, and it's basically just defining like the shape of the data. So rather than just using a map, it is defining a map, defining a Clojure map. So we can see here. So this is the Clojure map that we're using to define the schema, but we're actually specifying the type of the data within inside the map as well. So we're not just going to include any old data, which we can do in Clojure. We're specifically saying the kind of data we want to see to have a valid pizza. If we're going to, so our pizza name should be a string. So we're going to reference our names by a name rather than say like a number. So we're not going to say pizza 17. We're going to have pizza like pepperoni pizza, chicken pizza, vegetarian pizza, that sort of stuff. We're going to have size, and here we're specifying, as we saw before, we can only have certain sizes. So there's no kind of extra large pizza. There's no extra large pizza that's not a pizza that's valid here. And the same thing for country, we've done that as well. So we could add a different country, UK, oops, UK. So we might have shops only in certain, like pizza shops only in certain countries and cities. So here, but we're not specifying here like specific cities. We might need to specify another enum, which we're doing here, so another enumeration of things that define city as well. So again, it allows us to, if we're going to order a pizza, then we need to define specifically what city and maybe even what branch, what address of the pizza shop that we want to order a pizza from, if we wanted to evolve this this schema. And then we could also have optional keys as well. So these don't have to be, so these can be in, but don't have to be in the pizza. So we've got a description here, and this is going to be, this is just going to be a schema string as well. But look back at our Swagger, we can see that that's what's defined here already. So this is what it's going to look like. So we've got name, string, description, string, size, blah blah blah. So it's just an example, but it shows you, yeah, the options there. So we can now use UK as well in that one. And what else we got? So let's look at the APIs. That's maybe too big now. A little bit smaller. Yeah, so we've got, so I've updated the API Swagger definition. It's still in the same location, but I've given it a name and a proper description and pizzas, and I've given it in the tags I've given it a name. So we're actually going to use this specific pizza and ferry API. So you need to update these tags for Swagger to come in along and go and pick up. So this is the configuration for tags, and say, okay, well, it's going to go through all the tags and document them. So we put a tag in our context, which defines our APIs, and then it will come and pick it up, and Swagger will document all the things, all the gets and the posts, and any other APIs that we've defined inside this particular context. And if you want to have like multiple contexts, if you've got you're doing a leaderboard for like some online games, you might have different kind of APIs contexts for each game, and therefore you need to have a specific tag for each game as well. I'll do an example in another broadcast where I kind of show you that. Okay, and then there's the API definitions itself. So I've got plus. So this is using the kind of get function like we used with our server-side application last week. We had a get, so this is the protocol, the HTTP protocol we're using. So we're coming from our browser and it's saying, get me the page, get me the API that has a web address of whatever the domain we're talking to, and this URI, this uniform resource identifier, or URL, specific instance of that. And so whenever we go to /plus, then this is the API it's going to get called. We're defining the return type, which is going to be long, so it's going to return a long integer, so like a whole number rather than a fraction. We're defining the query parameters, so this is the X and Y values that we're taking in, and defining again what their types are. And this is a summary. This is the summary that gets added to the documentation in our Swagger. So we go back to Swagger for a moment. We can see here that this is the summary that gets added from there. So again, this is useful for Swagger to be able to document what our API does. And then it's going to return, if everything's okay, it's just going to return a value. In this case, it's just going to return a map. Although this is going to get changed because if we're requesting a JSON file, then compojure-api is just going to return this. Is going to convert this from a Clojure map into a JSON data structure for us. So it's basically saying, okay, we're going to return a map, and there's a key called results, and in the results, the value of results is our is the result of calling this function that we have here. So we just basically built in this function straight into the API. Obviously, this is okay for a very, very simple function. If we got some more complex ones, we might want to take that out into a helper function. I'll show you that in a moment. So here we're just adding X and Y together, and we're going to return the results. So we get X and Y from the query parameters, and we just return the result. And we've already seen that. So I've added here a second API call that's fairly similar. And this is just called calculator. It's a very simple Lisp style calculator. So we're going to take the operation. It's not really an operation, but it's actually a function. We're going to return the same kind of results as a long. Our query parameters a little bit are pretty much the same. There's one extra one here. So we're adding this op parameter in as a string. So we're going to take in a string, which is going to represent whether we want to do plus, minus, times, multiply, and so on. And then it's also going to take two values in as well. And this calculates two numbers. And this time, our OK results is going to be the call to this utilities calculator op file. So if I open the utilities namespace, this is just a very simple Lisp calculator. I've got I think we might have covered this in the last episode as well. So we've got basically a map that's just mapping the strings that we're going to get on our web address for calling the API. We're going to get a string of plus, and then that's just mapping that to the actual plus function, separate from minus, and so on and so on. And then we're going to use colon to represent divide, because if we put a divide character in our URL, in our web address, then that's going to mean something else inside a web address. So we have to use something else to represent what divide is in our URL. And then we've just got this calculator function, which is what we call from our API. So we're just calling utilities calculator. And this is just getting the particular function. It's checking we've got a valid function. So if somebody puts in something that's not in there, then we're just going to return a string. If it is in operands, so if this returns a value, then we're going to return the call to that function. So that would be plus, and then 1 and 2, for example, if that's what we put in on the URL. And so you see, yeah, we're just calling that, and that will, again, I'll just return us a value here. And so we're just returning a map with the results of calling this function. And we could just put in here a function call as well, which returns a map that we want. Nope, no questions so far. And then another really simple one, I guess I probably could have started with this one actually, is the dice roll. So I've created, so if we're going to do kind of online gaming, Dungeons and Dragons type game, we might want to be able to call a rice. So this is a roll of a dice and see what result we get. So this is a very simple way to kind of have a API for your dice. As it's Dungeons and Dragons, then we have to use a 20-sided die for Dungeons and Dragons, because there's lots of different scenarios around that. But pretty much the same. In this case, where we're not returning a specific, we're not returning like a built-in type. We're returning a type that is one we've created. It's a schema that we've created, a specification for dice roll results. So we go back up here. I've done a very simple schema here, just using this def schema function. And we're basically just giving a name to the schema, and it's just a simple map that is going to contain a result, and that result is going to be of a type integer. So that's basically our schema, but that's the that helps us define what we're actually going to return and make sure that what we're returning is valid. And so it's going to summary describes it, and then we're going to return a map which contains the result key, and that key points to the result of doing. So randint just will generate a number from, in this case, from 0 to 19, because it's 20 exclusively. So in order to get 1 to 20, we just take that result and just increment it by 1. So this will give us a range of like a random range of numbers between 1 and 20. So let's see, let's go and start this. So going back to my project. So this is the project I'm looking at now. So we've got there, yes, that's the right one. So we do lein-ring server. Obviously, if you've got multiple servers running, then they'll have a port conflict, but this is the only one I'm running, so it should be fine. And you can see that the Swagger is different. I've got a properly documented Swagger now, so it's just picking all that up from the Swagger configuration. I'm going to show hide. Oh, we've got lots of yes now. So the dice roll, and this is the description of it, the summary. So here, it's a get, so we don't need to provide any parameters in this case, and we can just try it out, and we get a dice roll, and we can keep on pressing this, and we can see we get different results values down here each time. And yeah, it looks like we have 0, at least 1 to 20, at least 2 to 20. I did see a 1 there as well. Yeah, so we're definitely getting random within the context of how random randint actually does it. But yes, it's pretty random, and it's random enough for our Dungeons and Dragons game, I think. Okay, so that's a nice simple get, but it's also using our a nice simple schema just to make sure we're defining what's going on. And let's go back to, oops, there we go. And then there's original pizza. Oh yes. So here this is the original pizza that came in the template when we created the project. And so this is a post protocol, so we're actually pushing some data to the API, and then the API will use that data to customize the result that we're getting. We're going to return a pizza type, so it's not going to be a long or an integer. This time, again, like the dice roll, it's going to be a specific type that we've defined. And it's kind of convention to use these as kind of like uppercase names, so uppercase first character in the names, just to kind of show you that it's a custom type. And the body we're going to return, so this pizza API is just basically going to return the pizza that we supplied. So this is just mapping a local name of pizza, and it's going to return the pizza value as the result. So the pizza value is already a piece of JSON, so it's just going to return the same JSON there. We've seen that already. And a similar thing I've done. So I've also done a post for a ferry company. If you're in Britain, you might kind of get the subtle kind of joke on this, but basically I've taken the pizza specification and just created a ferry company from that as well instead. So we go back to so we go this. So this is this schema for pizza, and I've just done a very similar one for ferry company. I've just changed a few of the bits and pieces. So instead of size, it's number of ferries, and country is Leiningen, and then the description. And the idea is that if our function, I write a function that would check to see if this ferry company has the right number of ferries, and if it doesn't, then we're not going to register it. If it's got ferries, then we can register it as a ferry company. And I also added a customer there as well. Let's go back to there. Oops. It's very easy to add this, and did I? I don't think I actually finished this, did I? I haven't actually written the ferry company applicant. Yeah, I haven't written the ferry company thing. So this is just going to return a ferry company, whatever we provide. So this is like an echo thing, but I probably need to, yeah, ideally I'd write a function. Oops. And I would go in and check. So I need to go and create that function. I'm going to create that in the thing. And then, yeah. So if I'd pull in the, so like if UK, if UK, just a bit of pseudocode, I haven't really written this yet, then registered, and then, we don't have any ferries. If you're in the UK, we don't have ferries in the UK because all the companies are owned by different countries, and so we don't have any ferries, which could be interesting after March. So this is just a bit of pseudocode that I would kind of finish off, and we return registered in there, and rather than just echoing back the ferry company, so you get kind of a result. So you define in the contract of the API what to kind of expect that way. And so that's it's pretty simple just to keep like define whatever kind of APIs you want. These are all fairly simple, and it's not massively complex. So you can either just define something that takes built-in values, or you can define your own values using the schema. And again, the schema is fairly straightforward. This is very similar to the Clojure spec as well, which is a new way of kind of defining contracts and specifications for your code that's out in Clojure. And so it's quite a nice way to kind of get used to it. And it just means that your API is checked. So whenever you're kind of talking to external systems, it's always nice to kind of check the structure and shape of the data you're receiving and sending out, because it kind of helps you minimize any issues. And if there are issues, then it helps you find what those issues are, as we saw before. Let's have a brief look at the tests. So let's look at the test space. So there's the core test file that we've got. And I haven't added any tests yet. I'll add some more tests over this next few days and push them up. But just to show you a little bit of the Cheshire library before we wrap up. So the Cheshire is there for parsing JSON for us. So we can. I've got a JSON file here, which I'm going to pull in. Let's just have a look at that. See if we can probably. So this is just a JSON file that's defining our pizza. This is a pizza I quite like to see. I'm kind of a bit of a pepperoni obsession, but it'd be nice if if there's a vegan version of pepperoni. It'd be much healthier for my diet. It's of size XL. It's coming from Poland. Actually, that should be Finland, really, shouldn't it? Temporary is in Finland. And got a description. So this is a JSON file that follows the specification that we defined for our pizza. And if we and we can slurp this in. So slurp is just reading a file from the file space. And because the file's inside the class path, it's actually just in the root of the project. It will just read it in for us. If you were going to use files in a normal project, you'd probably put them under resources public inside your project. So let's do space. No, not space. Ooh, I've forgotten how to evaluate. Am I running? Already running a REPL in this as well, so it should just give me the results. And you can see it's giving us the results as a JSON file. So it's got all the encoding stuff in there as well. So this is just reading. This is just Clojure reading in a JSON file. So we've got like the carriage return, and we have to escape all of the quotes and so on. So it's not really something you'd want to work with directly in there. It's a little bit messy. So we can use the Cheshire library to parse this string for us and tidy it all up, and essentially create a Clojure map for us as well. And so we're still slurping in our file, but then we're going to wrap that around using parse string from Cheshire, and it creates our little map here as well. And we can also pretty print that out. So if you use clojure.pprints, preprints around there, this does push this to the REPL, but it shows you in a much nicer form. So I just usually copy it from the REPL, and so I just copy the value that's been printed in the REPL from there. Or you can just have the REPL open, you can see it when you run this as well. So it's just going to help you see the structure of the REPL, of the map that Cheshire is generating. So you can play around with those and add. I started finding a test there. Ooh. Okay, I changed that. And I'm going to write some more tests in this. I'm going to write some more JSON stuff, and I'm going to start building a few different APIs that we can have a look at next time, and we'll start consuming those APIs in for now just in another Clojure server-side app, but eventually we're going to start consuming those inside a Clojure script client-side application as well. So like a reagent style application. Alrighty. Well, I hope it gave you a nice kind of intro into building an API, and you can see how fairly simple it is to actually do that. Relatively simple compared to doing it in some other languages, and you could actually just write all this inside. You just using a Clojure and Composure app, but compojure-api gives you a little bit extra help to get going and gives you a few gives you a few little tools to kind of help you do this, including schema helps you define the structure that your API is going to take, the data that you're going to take, and using this API in context. So using this context macro, it helps you create all the different APIs very, very easily. And yeah, so it helps just build those up nice and saves you a little bit of time. Also keeps the code pretty simple. Once you get used to, if you're used to using def roots inside Composure, then context is fairly simple to get used to on top of that as well. All right, thank you very much for listening, and we'll see you next time. We'll continue doing some more API stuff. Thank you very much. Goodbye. Bye-bye.